Okay, in this video, we're going to talk about solving quadratic equations. Okay, remember there are four methods to solving, so this is method one. Okay, and this method also works for any type of polynomial. Okay, so it could be a cubic function, a quartic function, quintic, and so forth. So if a function can be factored, then we can use that method to solve it. Okay, but one big thing that you want to focus on is that the equation must be set equal to 0. And the reason is because something called the zero product property that says when two things or more are multiplied together and make 0, one of them or both of them have to be 0. So it only works for 0. It cannot be any other number. Okay, so in order for us to use factoring by solving, we have to have a 0 on one side. So for this first example, x squared plus 5x is equal to 6. We're going to take the 6 and move it to the other side. So remember, when you move from the left to the right or vice versa, make sure you change the sign. Now you've got a trinomial set equal to 0. So remember, with a trinomial, we're looking for two numbers that multiply to the last number and add to the middle. So I want two numbers that multiply to -6 and add to 5. So if you want to just write that on the side. And so I think 6 and -1 should do. Okay, double check again here. In order to multiply to a negative, you need one positive and one negative, and I need them to add to 5. So I think that should work. X plus 6, x minus 1. Okay, and again, here's the set equal to 0 part. Two things are being multiplied together. So the only way for me to multiply and get 0 is for one or both of them to be 0. So we'll then take both of these factors, and you're going to set them to 0 individually. So like maybe x plus 6 was the 0, or maybe x minus 1 was the 0. And so we're going to subtract 6 from both sides to solve. Add the 1 to solve, and you have two solutions here. Okay, so both -6 and +1 should work. Again, checkable. So remember that we can always take these solutions, go back into the beginning equation, substitute, and we should get the same thing on both sides of the equal sign. Okay, so we can always check that equation. Okay. For the second one, so again, need to make sure you have a 0 here. So let's move that 28 to the left-hand side. Okay, and in some cases you might need to reorganize. Like let's say you were moving over a term that contained an x, you'd want to make sure you put it in the middle of the x squared and the constant. So just make sure it's in an order that you recognize that we can factor. So now we've got x squared minus 3x minus 28 equal to 0. Again, a trinomial. So you're looking for two numbers that multiply to -28 and add to -3. So I think if we do x minus 7 and x plus 4, that should work out. Okay, so -7, +4 multiplies to -28, adds to -3. So again, we'll take this, set it to 0. Take this, set it to 0, and we solve twice. Okay, so typically with quadratic equations, we should end up with two solutions at the most. In some cases, you might have less, but it's possible that we have two solutions. Okay, so those would be it. Okay, so both of these are trinomial factoring. Okay, so we could do the same thing with just GCF factoring or any of the other patterns that you've got. But also take a look at an example where we might want to move things in a different order. Okay, so notice that you've got 15 minus x squared is equal to 2x. Okay, and in this equation, you've got the x squared term on the left-hand side as a negative. Okay, so it's really difficult for us to do the factoring when that very first term or the highest exponent is negative. So it's almost always easier if we change its sign. Okay, so you could do that one of two ways. We could multiply through everything by a negative. That would fix it. Or we could just move the left stuff to the right instead of the right stuff to the left. Okay, so let's get the 0 on the left-hand side. So again, here's where I'm going to reorder a little bit, because when I move that negative x squared to the right, it becomes a positive, and I want to put it as the first thing. So I'm going to push that 2x over a little bit. That's already there. And then the 15, we're also going to move to the other side. It's positive right now, so when I move it over, it becomes a negative. So remember, anytime you swap something left, right, or right, left, make sure you change its sign. Okay, so now we want two numbers that multiply to -15 and add to 2. So it should be a +5 and a -3. So we take both of these individually, we set them to 0, and then we have two solutions, x equals -5 and x equals 3. Okay, so just to show you one more example, because sometimes they get so basic we get lost. So with grouping, with trinomials, nasty trinomials, works just the same. So if you can factor it, factor set equal to 0. But let's say we just had a GCF. So 3x squared equal to 6x. Okay, so this is a case where sometimes we are tempted to divide by x, which we cannot do. Okay, so I'm just going to put here, cannot divide by x to solve. And the reason is because x could be 0. So I don't know what x is at the moment. X could be 0, in which case I can't divide by 0, and I'm eliminating a potential solution. Okay, so again, stick with the rule. The rule is we have to get a 0 on one side. So I'm just going to move that 6x to the left by subtracting, and then I can factor. So I have a GCF. I could take out a 3 and an x, leaves me with an x minus 2. And from here I can keep going. So again, do not divide by x in the course of solving. It's not allowed. Okay, we don't know what x is. I could end up dividing by 0 and eliminating a potential solution. Okay, so from here we take both of these and set them to 0. Same thing like we do before. Okay, but notice that in this case, the 3 doesn't really affect the solution. So I could divide by 3, 0 divided by 3, that's still 0. So really this 3 does not play into my solution set. Okay, so please be careful of that. 3 doesn't equal 0 ever. Okay, so it doesn't play into my solution set, but we have this x that gave me a 0. We have the x minus 2 that gives me a 0 at 2. So I still have two solutions. Okay, and that is your solving by factoring. So we'll try another one where we are using the other three methods.